This is the first lesson in our new unit here on Introduction to Quadratic Relations, but before we get into quadratic relations themselves, we're going to have to review some stuff on working with powers and working with exponential expressions. So this stuff is covered in sections A and B of your learning guide. So by the end of this lesson, we want to be able to evaluate powers using order of operations, and this is stuff that I think you did back in grade 7 and 8 and 9. Combine and simplify powers of the same base, including those with coefficients. So you looked at this in grade 9. I know without the coefficients, so we'll do it without coefficients first, and then we'll add in the coefficients, just so everybody knows how to do it. And then some new stuff here is the last 2 points: simplify and evaluate expressions with negative exponents, and evaluate expressions with the exponent 0. So I think this might be split into 2 videos. We'll do the working the operations with exponential expressions first, and then we'll get into this stuff on negative exponents and exponent 0 in the second part, or the second video here. So just to kick us off here, what are we talking about when we talk about powers? Well, here are some examples of powers right here. 3 to the power of 4. The 4 is our exponent. The 3 is our base. And what does 3 to the power of 4 mean? Well, it means, a power means repeated multiplication. It means we're taking this number that makes up our base, 3, and we're multiplying it by itself 4 times to get a number like 81. All right, so if we've got something like negative 2 to the power of 3, our base is this number in brackets, negative 2. And it includes both the 2 and the negative. And of course, our exponent is a 3. And this means, again, repeated multiplication. Negative 2 times negative 2 times negative 2. So we've got 3 negative 2's that are multiplied together. And because this is a negative base, we've got to multiply the negatives together. Negative 2 times a negative 2 is going to give us a positive 4. Just multiplying these 2 terms together, we still have a negative 2. And then we get a negative 8 as our final answer, because that positive times negative gives us a negative. So we've got to be careful of the signs when we have negative signs in our base when we are doing this repeated multiplication. So the other thing we have to be aware of is order of operations. So if we've got something like negative 4 to the power of 2, this of course means negative 4 times negative 4. We're doing the exponent first, right? This is BEDMAS, so we do brackets. There's nothing to do in the brackets. Then we do our exponent, which means do this repeated multiplication. So we have negative 4 times negative 4, which is going to give us a positive 16. In the second one here, notice the negative sign is not part of the base. It's out in front. So this is like negative 1 times 4 to the 2. Okay? If we're evaluating something like this, we have to do the exponent first. So 4 to the exponent 2 is going to be 16. We think of this as negative 1 times 16, which is going to be negative 16. So it's like that negative sign is just sort of hanging around out front until after we've evaluated that exponent. When we get something like the third one here, negative 4 to the power of 2, it's not immediately clear whether the negative sign is part of the base or it's not part of the base. In situations like this, assume that the 2 only applies to the thing that's right next to it. So without the brackets, we want to think of this as negative and then 4 to the power of 2. So again, this negative, or this multiplication by negative 1, is going to be the last thing that happens. So this is like negative 16, or just negative 16. Okay? So we need to be aware of things like this when we're evaluating these exponential exponents. So a bunch of examples here. If I've got negative 7 to the power of 2, that negative sign is part of the base. Negative 7 times negative 7. 2 negatives are going to give me a positive. 7 times 7 gives me 49. If I've got negative 7 to the power of 2, I think of this as negative 7 to the power of 2. So negative 49. The next one down here, negative 3 to the power of 3. Negative sign is out front. 3 to the power of 3 is in brackets. 3 to the power of 3, 3 times 3 times 3 is 27. So negative 27. In our next one here, we've got negative 3 to the power of 3. Again, we think of this as negative 3 times negative 3 times negative 3, with the negative being part of the base. But if we do this in stages, negative 3 times negative 3 is going to be positive 9 times a negative 3. Negative times a positive is going to give us negative 27. So those two are equivalent, even though despite the difference in terms of what the base is. These last four at the bottom all have something 1 as our base, or negative 1. So we know that 1 to any exponent is just going to be 1, because 1 times 1 times 1 times 1, however many times, is still just going to be 1. So the only trick with these ones is, again, keeping track of that order of operations. This first one here, I guess I'll write this underneath. The negative sign is out in front, so this is going to be negative. Let's fix this a little bit. Try this again. This first one here is going to be a negative sign, and then 1 times a negative sign, and then 1 times 1 times 1 times 1. So those four ones multiplied together are just going to be 1. So we're going to have negative 1. Negative 1 to the power of 4, on the other hand, is going to be negative 1, negative 1, negative 1, and then negative 1. Two negatives make a positive, so we can think of this as positive 1 times positive 1, just grouping these together, which is going to give us a positive 1. Negative 1 to the power of 5, negative, and then 1 to the power of 5 is just 1, so negative 1. In this last one here, we've made it a little bit trickier. We've got a negative sign hanging around out front, and then we've got negative 1 to the power of 5, so negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Anytime we have like an odd number of these negative terms, so like 3, 5, or just 1, we are going to end up with a negative sign left over at the end. So our answer is going to be a negative. So this is going to be negative, and then in brackets, negative 1. But those two negatives are going to cancel to give us a positive 1. Okay? So that's just order of operations using powers. Now, what about when we are multiplying, dividing, or have powers of powers? So simplifying expressions involving powers with the same base. So first, let's look at multiplication. When multiplying powers with the same base, okay, so multiplying, the base is going to stay the same, and we add our exponents. So in our first example here, we've got 3 to the power of 3 times 3 to the power of 4. Our base is 3, so our new base is still going to be 3, and we are going to add our two exponents to get our new exponent, 3 to the power of 7. All right, same thing with our next one here. Our bases are all y, so we're multiplying these 3 powers with the same base. So we're just going to add up the 3 exponents. 4 plus 7 plus, we don't see it here, but there's an exponent of 1 there. So this is going to be y to the 12th. And our third one over here, our base is negative 2. So in our simplified power, our base is going to be negative 2. Again, we don't see the 1 there, but we assume it's there. We add our two exponents together. 1 plus 8 gives us a new exponent of 9. If we are dividing instead of multiplying, instead of adding the exponents, we are going to subtract the exponents. But again, the base stays the same. So if I've got 5 to the power of 9 divided by 5 to the power of 4, powers have the same base, my base is still 5. I'm going to subtract those two exponents to get 5 to the power of 5. Similarly, if I don't have a number as my base here is a, this is going to be a to the 7 minus 5, or a squared. And again, in our third example, even though we don't see the exponent of 1 there, we assume it's there. Our base stays as 9. 5 minus 1 is going to be 4. If we have a power to another, raised to another power, or like these two exponents, a power to raised to an exponent, we, again, our base stays the same, and we're going to multiply our exponents. So 6 to the 3 to the power of 4, we just take that 3 and that 4, and we multiply them together. 6 to the power of 12. Okay. X to the power of 5 to the power of 2, x to the power of 5 times 2, x to the power of 10. Okay. So these rules you all learned and practiced last year in grade 9. The only complication we're going to add here is, what if these terms have not just a base with an exponent, but they have a coefficient out front? Okay, so if we look at our first term here, 3x to the power of 3, we still have our exponent of 3. We still have our base of x. We now have a coefficient of 3 out front. Coefficient. So what do we do with these coefficients? Well, we treat those coefficients just like they were numbers when we're multiplying, right? We're multiplying our two powers here. So we know that the base is going to stay the same. We are going to add the exponents, but those two numbers out in front just get multiplied like we would multiply ordinary numbers. So if I've got 3x cubed times negative 2x to the power of 4, those coefficients, 3 times negative 2, I'm just going to multiply those as normal. And then when I deal with my x to the power of 3 and x to the power of 4, I'm going to use the rules that we just covered. Base is going to stay as x. I'm going to add those two exponents together. So I'll get negative 6x to the 7 as my simplified answer. Okay. If we have more than one variable here, or more than one base, we just have to match up the things that go together. Okay. The negative 6 and the negative 4 are both coefficients, so we are going to multiply them together. Negative 6 times negative 4. Right. Moving along, we've got an x squared and we've got an x to the power of 5. We're going to combine those together. We'll have x to the power of 2 plus 5 is going to give us our new exponent. And then finally, we've got a y and we've got a y. We're going to combine those together. Our base is going to be y, and our new exponent is going to be 3 plus 1. So putting this all together, negative 6 times negative 4 is a positive 24. X to the 7 and y to the 4. Okay. Same rules are going to apply if we're doing division, right? We're going to take our coefficients and we're going to divide them. So 25x to the 9 divided by 5x cubed. We're going to do 25 divided by 5. And then x to the, instead of adding the exponents, we're going to subtract the exponents. 25 divided by 5 is going to give me 5x to the power of 6. Okay. Same thing if these two things are stacked up one on top of each other here. We are going to do our division. So again, we're just matching up the things that go together. The coefficients go together, 45 and negative 9. So I'm going to treat those as 45 divided by negative 9. Okay, there's our coefficients. Then moving to the right, we've got an A and we've got an A. We can combine those together. Those are going to give us an A to the 2 minus 1. And then we also have B terms. We want to combine those B terms together over here. We're going to have a base of B and subtract the exponents. So negative 5, A to the, well, 2 minus 1 is 1, so we'll just leave it as A. B to the 4 minus 2 is just going to be 2. Let's change that to a 2. b to the 2. All right. Okay. So this same sort of thing is going to apply if we are have powers to the power. Okay. We are going to, again, multiply the exponents. The thing to realize in this case is that we need to apply this exponent that is outside this thing in brackets. It applies to everything that is in these brackets here. So if I'm looking at this first one here, 2y to the power 4 to the power of 3, this exponent of 3 applies to the 2, and it applies to the y to the power of 4. So I can think of this as 2 to the power of 3 times y to the power of 4 divided to the power of 3. Y to the power of 4 to the power of 3. Now, 2 to the power of 3, we know is just going to be 8. Y to the power of 4 to the power of 3, we know we need to multiply the exponents. Y to the power of 12. Okay, so everything inside those brackets gets raised to the power of 3. Okay. Our next example here, I've got negative 4 p cubed q to the power of 2, all of that to the power of 3. Take each of these things, 1, 2, 3, inside the brackets, and raise them to the power of 3. Negative 4 to the power of 3. Okay. P cubed, p cubed to the power of 3. Q squared to the power of 3. And then evaluate them separately. Negative 4 to the power of 3 is going to be negative, because it's an odd exponent, 64. We're going to have a p. 3 times 3 gives us 9. And then q, 2 times 3, gives us 6. So 64, p to the 9, q to the 6. If we have a more complicated expression, the same rules apply. This exponent of 3 applies to everything inside these brackets here. It applies to this 2, this x squared, this negative 5, and this y here. So let's just write out our fraction line here. Up in the numerator, we'll have 2 to the power of 3, x squared to the power of 3. In the denominator, negative 5 to the power of 3, y to the power of 3. And then we can evaluate each one. 2 to the 3 is 8. X, we're going to multiply the exponents to get a 6, all divided by. Negative 5 to the power of 3 is going to be negative 5 times 5 times 5 is 125. And then y to the power of 3 is y to the power of 3. Okay. So that is the kind of stuff that you need to be able to simplify those expressions involving exponents. All right.